Okay, here's what they can make a question look like when they don't want to allocate so many marks. So in this particular question, I'm given the situation, but they've done some of the work, the ranking work has been taken away from us. So I've got geology students, I've got medicine students, and it tells us they've done all the ranking that needs to be done. They've got the total of the ranks of the geology students for us to work with. And I've got a test to do. So step 1 is going to be to state my hypotheses. It's Mann-Whitney, so H0 is always the same. H1, well, I can say that they come from different populations, but I've got to look closer. It might be one-tailed, it might be two-tailed. So what's the claim? The claim is that there is a difference in handwriting legibility. Okay, it's not saying a difference one way or the other, so therefore H1 is that there is some difference in the average legibility. So those will do as my hypotheses. On to calculating the test statistic, and I can start from the fact I've got the total of the geology ranks is 145. Now the Mann-Whitney formula from the formula book for working out U is I have to do what the formula book tells me to. I've got to do T minus n brackets n plus 1 over 2. Okay, so for the data I've got, well, I've got the T, that's this value here. N is the size of that particular sample. So I've got to know how many students there were that this applies to. This is geology. So how many geologist students were there? There were 10. So I've got to do 145, and I've got to do minus 10 times 11 over 2, which is going to give me a value of 90. Okay, now that might be, if it's significant, that might be in one of the tails. Which tail might this be in? It could be the upper tail or the lower tail, but the table that I work with in the formula book works with lower tail critical values. And to swap between the two tails, I need to do m times n minus my u value. So I've got a possible u value here of 90. The other possible u value is mn minus that first one. What's m and what's n? Well, n I've already got is 10. M is the size of the other sample, which was the 12 medicine students. So it's 12 times 10, and I've got to take away the 90. So that's 120 take away 90, which is the 30. And of these two, the only one that's got a chance of being in the lower tail is the 30. Okay. Oh, I should have said when I did H1 that we're dealing with, because it's just any difference, I'm dealing here with a two-tail test. Okay, and I'm testing at the 5% level for two tails. Okay, so I've now got my test statistic to work with. I now need the critical value, and the information I need for critical values, I need the values of m and n. Well, there were 12 medicine and 10 geography students, and I need to know that it's two-tailed, and I need to know that I'm looking at 5%. So on this page of the formula book we have two tables. But the first one, it applies when it's two-tailed and 10%. I need the other one because it's two-tailed and 5%. And then I need my values of m and n. They were 10 and 12. Okay, so m was 12, n is 10. So that gives me this critical value of 30. So the critical value is 30. And so my comparison is 30 with 30. So actually, in this particular case, they're equal. And we have to remember that for this particular case, the table here tells us, okay, that the critical region includes the tabulated value, which means if we equal that value, then it is indeed significant. So this is significant, okay, and therefore we're going to be rejecting H0. I should say it's significant at the 5% level. Okay, so I've done my comparison, but I now need to express my conclusion in context. Because I'm rejecting H0, we have evidence of something. So I've got evidence of, well, my alternative hypothesis was just that there were some differences in the legibility. So I have evidence at the 5% level that average legibility is not the same, but I have to give the context for geology and medicine students. You always have to say this in full, in contexts. Okay. All right, now part B then says what were the maximum and minimum values that could possibly have been obtained for TG for the situation above. And they do ask this kind of thing. So we got a critical value of 30 from the TG they gave us of 145. We had to go via the top value. So this looks like this is a fairly high value, but it's not the highest it could have been. So what's the highest and the lowest that my sum of the geology ranks could have been? Well, there were 22 students altogether. The very lowest total rank I could get for geology is when the geology students were the very lowest ranks from 1 to 10 that would have been. So the lowest is going to be 1 plus 2 plus ... plus 10. Okay, and there are clever mathematical ways of summing this, but you might as well just get out your calculator and add these up, and you get a total of 55. And the highest, well, that's when out of the 22 students, they've got the highest ranks they could possibly have had. So it's going to go up to 22, so I need 10 numbers going up to and including 22. It's actually 13 plus 14. If you want to write them out and check, there are 10, but it needs to go from 13 up to 22. In fact, it's all of these numbers with an extra 12. So I can do the addition again, but the smart way to do this, I guess, is to add on the 120. So that would be 175. But you can do it just by adding up the numbers from 13 to 22. Check there are 10 of them. So this is the highest total, and this is the lowest possible total of the ranks.